So in this video, we'll talk about differential equations and the four types of differential equations that you'll encounter in this course. So first of all, we categorize differential equation by the highest differential that is in the equation. In this course, we only talk about first and second order. First order is if you have a y prime, and that's your highest derivative within your equation. And second order would be if you have y double prime. In your equation, it would be of a second order differential equation. If an equation includes y double prime and y prime, it's by the highest order of differential, so it would be a second order equation. And then within first order differential equations, the two main ways of solving them would be one would be that they're variable separable, which means that you can separate the variables into such form where you have f of y dy on one side and some function of x dx on the other side. And at this point, you can directly integrate the left and right hand side, and you'll get some function of x, some function of y will equal to some function of x, and you can isolate y to solve for the solution to your first order differential equation. Now, if it's not separable, such as if it's not separable first order differential equation, then most likely it will be a linear first order. And so a linear first order is a differential equation of the form y prime plus p of x, y equals q of x. Note that the coefficient of y prime has to be 1. The coefficient of y can only include functions of x and constants, obviously, and everything on the right hand side has to be a function of x or a constant. And from here, the solution for this differential equation will be of the form y times e to the integral of px dx will equal to the integral of qx e to the integral of px dx dx. And so this will be your solution to this particular differential equation. Then on the other side, we have second order differential equations, which are also split into two main types for this course. Well, they're second order reducible differential equations. And the first type is that the dependent variable is missing, which also, I guess, if y is a function of x, then it means that the variable y is missing. To solve these types of equations, we make a substitution such that v equals y prime and v prime equals y double prime. And then your second order differential equation becomes a first order differential equation with v prime instead of y prime. The second type of second order differential equation you'll encounter is when the independent variable is missing. So if y is a function of x, your x would be missing. And in this case, we make very similar but slightly different substitutions to solve. So your y prime would become v. We make the same substitution for y prime, but instead of letting v prime equals y double prime, we're going to let y double prime equal to v dv dy. And so when you encounter any differential equation, if you follow the flowchart, identify first whether it's a first order or a second order, then identify if it's a first order whether it's separable or linear, if it's a second order whether it has a missing dependent variable or a missing independent variable. You can apply each of these formulas or substitutions into your differential equations to make it easier to solve. Let us do an example. So say we have y double prime equals y times y prime. So I'm going to go back to my flowchart. I'm going to say, I can see that it has y double prime, so I can say that it's a second order. So now I'm at my second order. And then I also see that I have a y, but I don't have x. So I can say that my independent variable is missing. So let's make this substitution into this equation. So we get v dv dy equals yv. Now we can divide by v on both sides and get dv dy equals, at this point we have a first order separable differential equation. We can say that dv equals y dy. Integrating both sides, we get v equals half y squared plus c. So unfortunately we're not done at this point because we want our equation to be in terms of x and y. So let's substitute v back for y prime, which we can also write as dy dx equals half y squared plus c. Now this is also variable separable because I can move all my y's to the left hand side and all my x's to the right hand side. So we would have 1 over half y squared plus c dy equals the integral of x dx. So the right hand side, it's fairly easy to integrate. It would just, whoops, it's not x dx. It would be 1 dx. I got ahead of myself. So the integral would just be x plus d. And I'm using d here because I already have a constant that I've added from the first time I integrated. The right hand side, we can actually factor out 1 over c. You have 1 over c times the integral of 1 over 1 plus, and I'm going to write all of this under this a square and get 1 over root 2c y. And we know that this is equal to 1 over c times the square root of 2c by chain rule of arctan of 1 over root y. So our final solution is x plus d equals root 2c over c times the arctan of 1 over root 2c y.